air coming from the drying chamber. Okay. Just take it back from the drying chamber, from here. Okay. Put a flowmeter down to the scrubber. In the scrubber, also add water here. 8 standard liters per minute in here. Okay? 8 standard liters per minute. It has a regulating valve. It also has a flow meter valve here. Make sure we have the right amount of water going into the scrubber. Inside the scrubber, we have 2 big stainless steel mesh filters here. These filters are designed in a special way to give a lot of surface area. You have a lot of surface area. The filter holds water. It holds the water. If you take this filter out, put it in a bucket of water, pull the filter out, the water will stay, and you'll see it drain out. Okay, it actually, because of its surface area, it holds water. When holding water, it also cleans the air and cleans the water. So we need to clean the air coming in from the septic chamber. We need to clean the water coming in from the process. So the scrubber, as its name says, we scrub the air and we scrub the water. Clean it. We'll pull this out so you can have a look at this. Okay? It's quite easy to do that. Because during your weekly care, CPMS service, you have to remove this. It's good to hold these extra ones in stock. Because you can take one out and you can put it in an acid bath and reuse it. Or you take it home and test it for cleaning barbecues. The best thing ever for cleaning a barbecue. I do not have it. Okay. So the scrubber purpose, scrub the air, scrub the water, then the scrubber then takes the water to the water ring compressor. Okay? The water ring compressor. The first item is the scrubber. We'll come back to the separator. So now we have the water ring compressor.
Talk to the vacuum pump.
Yes, same shit. Same shit. Yes, same shit. But in Tetrapack for many years, we've always called it a water ring compressor. So it allows air and water to come in a big area and then pump out in a small area. I have a video I'll show you how it's mash pump. So what's important inside the compressor is the vane is offset from the housing. So as the vane is offset from the housing, it creates this big inlet, small outlet. But the water, when we bring it in, it goes out in centrifugal force. As it moves out in centrifugal force, we then create this opening, a narrow opening here. So big inlet, small outlet. Okay. This is the easiest way for an aseptic system to create the pressure in the system. So we've never ever used anything like a vane pump or a vacuum or an air pump, or we've used this since 1954. Correction, 1952. We've been using this pump. The only thing that's changed from the early machines to today, now this is frequency control. We have to control the speed. That's the only thing that's changed. The pump has never changed. It's always been the same pump. We only changed see, you need air, you need water. Water for the water recompressor. Okay. Is that okay? Good. I'll come back to the next one. The water separator. Before it goes to the scrubber, then to the compressor, then to the water separator. So from the water separate from the compressor, so this comes to the compressor. Okay. 0.27 bar or something like that. Over all my years, I don't care as long as I don't have an alarm.
Yeah.
So this is coming from the compressor. So mixed from the compressor we have air and water mixed together. So then we come into the water separator. If we look down this way, then you will see the inlet is offset. So we create a spiral with air and water inside the water separator. So when we create this spiral here, the heavy parts of the air-water mixture, water will fall down when the water gets in contact with the filter. This is the same filter that's in contact with the scrubber. So by the airflow and the spiral action, we then push air and water this way. Because of this filter now in the surface area, we hold a lot of water. So by holding a lot of water here, then it captures the water, then under weight of the water, then falls down. So the water just doesn't come in here and go out. Water and air mixture comes together and it spirals. As it's spiraling out, water and air come in contact. Filter. The filter holds the water when we have enough water in the filter, and then drops down. Okay? When it drops down, the bottom of the separator, we now have this float mechanism here, which is connected to a needle valve in here. Float comes up, the needle valve opens, and this now goes to dilution tank. Okay? So the water goes to the dilution tank. Up here, the dilution tank. This is where we dump peroxide. We will learn more about this with Charles. I cover all this in TGA Basic. I'll probably cover 6 later. Charles is coming back in or next week. Coming back anyway. So the water from the separator then goes to the dilution tank. The dilution tank dilutes any peroxide that's dumped from the peroxide bar into the dilution tank. So coming out of here will be less than 1 part per million after 24 hours in the operation. Dilute peroxide. Peroxide will not go straight to the floor because of the way the tank is set up inside. Charles will explain how this is set up inside here and how we dilute it. So, water separator. Also, inside the water separator, we have this level detector. High frequency vibration. This looks like a tuning fork. We'll pull this out. It almost looks like a tuning fork. Two prongs. Yeah, and it vibrates at high frequency. So the high frequency value will give an analog value out, okay, to the PLC. If you change, if this is covered with water, the frequency changes. So then we get no signal. Then the machine shuts down. Zero. Shut to zero. Machine to zero. Maybe. CRP. If you remove this, put it back in, make sure you put it in the right way. When it goes in, prongs go like this. Not like this. So don't move this around. So this is rotate 180 degrees. Because then water sits on here. Sits on here. And you have a different frequency. Machine shuts down. So be careful when you're putting it in. Because there's no locating pin. Just goes in. So make sure the prongs go in this way. So this is the level. It's a high frequency bar. Okay. This is overhauled during TPMS, whether it's 1,000 hours or 1,500 or 2,000. I don't know. Okay. We'll ring compressor. Now we have sterile airflow meter. So coming from the septic chamber, here we have the flow meter. Here. It's the same type that's in the filling system. Here. It measures flow. This measures airflow and product flow. This measures airflow only. Okay? Remember I opened up that window, I think it had top limit was 1,500 PA, the bottom was 100 PA. We had this area, and I opened up the tip up, that's from here, measuring the flow. We need to know what the flow is. Here. Because if we don't know what the flow is, here, we can burn this out. This element can burn out. And it actually is happening because this is slow. Because the compressor, if we measure high flow, the compressor can slow down. Okay? When the compressor slows down, we have less air. We had a situation once where this failed completely. And it was saying to the compressor, slow down, slow down, slow down, slow down, slow down, during production. So there was no air going through. Yeah. And it just blew up. So we need to know what the airflow is to control speed. Yeah. So these are tied together. Flow meter. Operates on a vortex principle. So here we have a flow meter, and depending on the flow, how much the vortex moves, the airflow. I've got a good video just to show you how. So depending on the flow, here you get a signal back. Say what the airflow is. So it just creates vortexes around this block here. So the higher the flow, the more vortex flow you have. Okay. I have a good video. This covers. So that's the flow meter. Then we have the heat exchanger. The heat exchanger is a air on metal heat exchanger. So we have inlet here. Where's this coming from? On the water, on the heat exchanger valve. This is coming from the water separator. So cold air coming in, going down to the superheater, then out of the superheater, and then regulated air going up here. During heat sterilization, this is taken out of the circuit completely. You have bypass. Going to the heat separator and out. There's no cold air coming in during heat sterilization. Want to reach 280 degrees, as you say there. It's only when sterilization is finished, move the heat exchanger valve. Remember I said downstairs just before lunch, it goes from 0% to 100%. So when we are at full bypass, we want heat as quick as possible at the sterilization point. Okay. So how's it work? On the inlet side, we have a lot of veins. A lot. Yeah. Okay. On the outset line, we don't have as many. We have smaller here. So this is designed, this is number 1. I think this is 2. 3, 4. And it's actually numbered.